Hi viewers, today I want to talk about fermenter. What is a fermenter? What are the parts of fermenter and its functions? This topic is coming under the paper Industrial Microbiology. Today we are going to give a look upon fermenter. Before starting with fermenter, let's see what is fermentation. Fermentation can be defined as a metabolic process in which the primary metabolite is converted into secondary metabolites. Okay, so it is a biochemical process. Details of the fermentation were given in the previous class. So let's move to the fermenter. Okay. Fermenter is also called bioreactor. It is a system that provides an optimum environment or the proper environment for the growth and metabolic activity of the microorganism. Okay, so that we can achieve the maximum production of industrial product. Okay. Otherwise, we can define the fermenter as a vessel in which sterile nutrient media and pure culture of the microorganism are mixed and fermentation process is carried out under aseptic and optimum condition. Okay, so the fermenter provides optimum condition for the growth of the microorganism and also for the fermentation process. Okay. It is important for the growth of the microorganism and synthesis of new product. Okay. The size of the fermenter ranges from 1 to 2 liter to 5 lakhs liter or occasionally up to 1 to 2 million liters are commonly used. Okay. Fermenter is generally made up of stainless steel. It is a closed cylindrical vessel. Within that vessel, we put suitable medium to which different microorganisms are added. This microorganism will carry out its biochemical activity and then it converts the raw material into useful industrial product. Okay. So this is the general information on the fermenter. Okay. Material used for the fermenter. Different types of material used for fermenter. The material used for designing a fermenter should have some important functions. First one, it should not be corrosive. Second, it should not add any toxic substance to the media. Third, it should tolerate the fermentation process or the sterilization process, and it should be able to tolerate high pressure and resist the pH changes. Okay. In designing and constructing a fermenter, a number of points must be considered that are listed here. Adequate aeration and agitation should be provided. Baffles should be provided to avoid the vortex formation. Should be a provision for the intermediate addition of antifoam agents and for the removal of culture during fermentation. And there should be a provision for the removal of carbon dioxide formed during fermentation. And there should be a adequate service provision for individual plants. Power consumption should be low. Temperature control should be provided. pH control should be provided. Sampling facilities should be provided. And the evaporation loss must be less. Okay. Minimum use of labor. Then the vessel should be capable of being operated aseptically for a number of days and should be reliable in long-term operation. So, these points must be considered while constructing a fermenter. Here, the design of a fermenter is given. Please note each and every part. Okay. Functions of these parts can be discussed. Okay. Next, parts of fermenter, which include impeller or agitator, baffles, sealing assembly, sparger or aerator, inoculation probe, sampling point, pH control device, temperature control device, foam control device, and bottom drainage system. First, we can discuss impellers. Impellers are agitation device. It provides proper mixing of the media and microorganism. And also, it helps in breaking the foam bubbles in the headspace of the fermenter. This foam formed during fermentation process can cause contamination, and this contamination problem can be avoided by the use of impellers. Impellers are mounted on the shaft and introduced into the fermenter through the lid. Impellers are made up of impeller blade, and the blade position may vary according to its need. These impellers or blades are attached to motor on lid. The important function of the impeller is to mix microorganism, oxygen and media. Okay, so it provides uniform distribution of the microorganism and media and oxygen. Okay, and also it can reduce the size of the air bubbles and can distribute the air bubbles uniformly in the fermentation media. So we can list out the functions or the objectives of the impellers as bulk fluid and gas part mixing, air dispersion, gas transfer, heat transfer, suspension of solid particles, and maintain a homogeneous suspension. Okay. Types of impellers. There are 4 types of impellers. First one, disc turbine. Second, vent or disc turbine. Then third one, open turbine of variable pitch. And fourth one, marine propeller. I will explain this type of impellers later. Next, we can move to the baffles. Okay. Basically, baffles prevent the counter flow of the medium and the formation of air bubble. It improves the aeration efficacy. Okay. Baffles are metal strips nearly 1/10 of the vessel diameter and attached radially to the fermentation wall. Usually, 4 baffles are used, but larger fermenters have 6 to 8 baffles. The function of the baffles is to break the vortex formed during the agitation process by the impellers. And second function is to improve the aeration efficiency. Okay. If this vortex is not broken, the fermentation media will spill out of the fermenter. Okay. That situation creates the problem of contamination. So, the baffles act as a barrier which break the vortex. Extra cooling attached to baffles to improve the cooling. There is a gap between the fermenter wall and the fermenter. This gap is to minimize the microbial growth on the baffles and fermenter wall. Okay. Next is the Sparger. You can see the Sparger in the diagrammatic representation of the fermenter as dotted lines. Sparger is an aeration system through which the sterile air is introduced into the fermenter. The Sparger consists of a filter called glass wool filter, and the glass wool filter allows or provides the sterilization of the air and gases. There are three types of Spargers, that are nozzle Sparger, porous Sparger, and orifice Sparger. Sparger is located at the bottom of a fermenter. Sampling point. It is the another part of the fermenter. It is used for the time-to-time withdrawal of the sample to monitor the fermentation process. Okay, so it allows the aseptic withdrawal of the sample from the fermenter. Sealing assembly. It provides sealing to the stirrer shaft, which is required to provide the agitation. There are three types of seal: packed gland seal, mechanical seal, and magnetic device. Okay. pH control device. If we consider the design of a fermenter, the fermenter has two parts, basic part and controlling part. The controlling part include pH control, temperature control, foam control, and oxygen control. pH control device check the pH of the media at specific interval of the time. So, this can adjust the pH to its optimum level. Okay. The adjustment is by the addition of acid and alkali. Okay. So, every fermentation require a particular pH range. That is the optimum pH range. Okay. During fermentation process, the pH range may vary from its optimum range. Okay. So, this optimum range can be maintained by the addition of acid and alkali. Example, calcium carbonate, NaOH, phosphates, etc. The maintenance of the pH in the optimum level is very important for the growth of the microorganism. Okay. Otherwise, we can say that the maintenance of the pH is very important for the synthesis of a desired product. Okay. Then, second control device, that is temperature control device. Temperature control device consists of a thermometer and cooling jackets and heating coils around the fermenter. Okay. Once more, temperature control device consists of three parts: thermometer, cooling jackets, and heating coils. During fermentation process, various reactions takes place in the fermenter. Okay. Heat is generated and released to the fermentation media. The increase in temperature causes detrimental effect to the growth of the microorganism or slow down the fermentation process. Okay. So, it is necessary to control the temperature by passing cool water through the jacket present around the fermenter. Okay. So the cooling jacket is present around the fermenter that can reduce the temperature of the media present in the fermenter. Okay, the temperature rise is due to the various chemical reactions takes place in the fermenter. Okay. Foam control device. It is placed on the top of the fermenter. Foam generated during the fermentation may cause to spill out of the fermenter and cause contamination. So it is necessary to remove the foam from the fermenter. The foam removal is by the addition of antifoam agent. Example for the antifoam agent is the maize oil, corn oil, lard oil, etc. The device consists of a small tank and that tank contains antifoam agent. Okay, the antifoam agent can break the foam. Next is the bottom drainage system. It is an aseptic outlet. It is present at the bottom of a fermenter and it is for the removal of the media with the product format. Okay, and the media with the product require additional procedures like purification and other procedures. Okay. Last topic is the valves. Valves used to control the flow of gases and liquids present in the fermenter. Okay, there are different types of valves: globe valves, butterfly valves, ball valves, diaphragm valves, and safety valves. Okay, finally we can discuss the functions of fermenter. Okay, fermenter does not cause any damage to the microorganism and it should be easy to handle and clean, cost effective, and it should facilitate the incoming flow of the inoculum, media, etc. Less power requirement and it is suitable for long-term operation and it maintains aseptic condition and provide proper aeration and agitation. Okay, so this is about design of a fermenter. Okay, if you have any doubt you can ask me. Thank you.